This video is an introductory overview of our project, the MRMI, also known as Multi-Runtime Method Intermediate, and a comprehensive overview of its working. MRMI is a technique with which we wish to achieve a program that could use the strengths of another program written in a different language to overcome its flawed areas and actually work in a production environment. Now, the idea of such a technique lies in the domain of polyglot systems. Wait, what is a polyglot system first of all? Well, these systems represent a modern approach to software development, allowing developers to harness the strengths of multiple languages and formats to create a sophisticated and high-performing application. Coming to the actual project, we need to make a communication channel between two different languages, and there sure is no simple magical way. So, we'll use a simple model of requests and responses as our communication model. And this brings us to the next part, which is finding a channel to bridge the runtime of both the programs. For those who don't know what a runtime is, it is a phase of program's lifecycle when it is being executed. Now, we would note all the ways to channel our communication model we can think of. First of all, we know we could read and write from text, JSON, CSV, binary, and many more kind of file types, right? Well, they absolutely can. Here, we can take a glimpse at the possibility of communicating through JSON or binary files to store requests and responses. Both of these file types have a smaller and less expensive electronic footprint. Sounds sweet and easy, doesn't it? Well, let's brainstorm through it then. We would have to do a lot of filtering and processing to retrieve the desired part of data, which becomes hard to manage in case it becomes too large. And if it does, we would have to pool it in memory to make finding desired data less processing intensive, but there still is a possibility that our pool size is exceeded on demand, but that is slow and inefficient. Remember, we wanted to harness the strength of different programming languages to save time and efforts. This doesn't quite seem like it. Trial and erroring this way could consume a lot of time, so we'd think of an already existing channel that is the closest in terms of using our communication model. What can it be? I can think of a server and a client communicating, wherein the client sends a request and the server sends back a response to the client's request. So, using socket-based communication as a channel, in our case, sounds about right. But one needs to have the prerequisite knowledge of sockets in computer networks in order to grasp the idea of the way we're gonna use it here. Please refer to the internet to read about it if you want, because including it here is quite irrelevant and distracting. Moving ahead, we can construct an analogy to decide which of the two runtimes plays client and server. And to do that, let's revisit the idea of polyglot systems where a program is harnessing the strengths. So, it is safe to say that there is a central program overseeing the subsidiary programs, and it is the one sending the requests and receiving responses. Well, that suggests that our main program acts as a client and the subsidiary programs act as server. Now, with our approach being clear, we may proceed to finding a way to allow both of the parties to parse requests and responses. To save time, we'll just go simple by using a strict typed command format to set rules for our intermediate so it can explain the intent of the request sent by one program to another. A request can look something like this, which the intermediate can parse step by step, like A. Split the request string by this delimiter, we get the function name and the argument part like this. B. Split the second part of the request string by this delimiter. Now we get all of the arguments with their class or type specified in the beginning, which can be parsed with a function to give us an array of parameters, which in this case are both string types, and in a sequence which can be directly fed into a function like this. And the subsidiary program would return the output like this, which can be parsed again by following the steps in previous example, and we get our message in a string format. This seems to be the end But the tricky part still remains, as with this project we decided to use C# for the master program and Java for the subsidiary program. Thankfully, Java has reflections, an API which provides a way to examine or modify the properties, methods, and constructors of classes dynamically even if the class details are not known at compile time. This way, our logic remains safe in binary form so it can be shipped to production. We can conclude this overview with the fact that C# and Java, which don't have any native reliable interoperability bridges between them, can now interoperate and span a wide range of functionality in a relatively simple and more effective manner than with JNI bridges. Thanks for watching.